The Lynx KF41, the next generation of military superiority. Engineered to endure on the battlefield of the future, an armored fighting vehicle that sets new standards. It combines speed with firepower and a sophisticated protection system that serves as life insurance for its crew. Developed in Kiel, the first armored fighting vehicles are manufactured in Unterlüß near Hannover.
The turret is on now, no collision, that was good.
Hungary, a NATO member, is the first country to adopt the Lynx and has built its own dedicated tank factory for it.
We started building in the spring of 2021. Today, this is the most modern tank production facility in the world.
Meanwhile, engineers are working in the lab to improve the interface between the soldier and the combat system.
This is the first of its kind, and there are more driving simulators, firing simulators, and desktop trainers to come.
It's a masterpiece of engineering. With its speed, agility, and seamless integration into the digital battlefield of tomorrow, the Lynx is built for any mission. The Lynx Armored Fighting Vehicle. It brings together advanced weaponry, a high level of protection, and cutting-edge sensor technology. It's one of Rheinmetall's latest innovations. As an armored fighting vehicle, it's designed to carry up to 8 infantry soldiers across the battlefield.
In addition to the onboard combat systems, we of course also deploy soldiers, an infantry squad in the rear compartment. All seats are all suspended from the ceiling rather than mounted to the floor. There's a simple reason for this. If the vehicle runs over a mine, the force of the blast travels through the floor, causing it to bulge. And if the seats were attached to the floor, the soldiers' feet would be touching the floor. The energy would enter their bodies unimpeded.
The Lynx is 8.49 meters long and 3.73 meters wide. Its unladen weight is 43 metric tons, and it can be upgraded to up to 50 metric tons. It has a range of around 400 kilometers and a top speed of 70 kilometers per hour. The tank is powered by a 1,155 horsepower 6-cylinder diesel engine that delivers 4,300 Newton meters of torque. It accommodates a crew of up to 11 soldiers. The driver sits at the front left, while the commander and gunner operate from inside the turret. The weapons package includes a 30mm automatic cannon, a turret-mounted machine gun, and an additional weapons station. Unterlüß, located in northern Germany between Hannover and Hamburg, is home to Rheinmetall's armored vehicle production. This site is a key industrial forge for weapons systems. Here, barrels and main assemblies for the Leopard 2 battle tank and the Panzerhaubitze 2000 self-propelled howitzer are major components for the Puma infantry fighting vehicle are produced in these same halls. And the Lynx is assembled here as well. Since 2024, the Lynx has also been in series production in Hungary. The tank hull is fabricated in Unterlüß, the first production step. Later, all components will be installed on this assembly. The use of rotating positions during welding ensures that technicians can reach every weld point safely and precisely. To prevent structural weaknesses, only downward welding is permitted, never overhead. The hull of a Lynx weighs around 10 tons. Unterlüß is the launch site for all initial variants of the Lynx series. No matter the configuration, the first vehicles are always built here. At this stage of production, the crew compartment is fitted with seating for the infantry squad. Much like an aircraft, each seat is equipped with individual lighting and a digital interface connected to the soldier's communication system.
It's pretty heavy, weighs around 40 or 50 kilograms. With this vehicle, there are 8 seats to install. It's pretty hard on the back, especially if you have to guide it through this. That's why we have an overhead crane. We can work really well with it.
The soldiers' seats are also ergonomically designed. In the event of explosions, mines, and grenade hits, the crew has to be protected as well as possible, but they also have to be able to evacuate the vehicle quickly. Belts and devices are adapted to these requirements. The seating arrangement and plenty of headroom also keep the soldiers safe.
The seat has more shock-absorbing components, like all the straps at the back here. They're there to help absorb any shocks. And of course, you're also much safer in the seat. You have a three-point harness to secure you firmly in place.
The seat modules are not bolted to the floor. On the contrary, they're actually decoupled from it. The occupants have the best protection possible in the event a mine should explode beneath the vehicle. Change of location, Hungary. The Lynx has also been built here in Zalaegerszeg since 2024 in series production. Hungary is the first NATO and EU country to equip its armed forces with the German armored fighting vehicle, an order valued at 2 billion euros, for which the world's most modern tank factory is being built in Hungary. A Lynx forge built in the open countryside.
From the very beginning, we planned the plant mainly around building the Lynx. We're building the Lynx for the Hungarian armed forces, and we have to be particularly precise and meet high standards for protection and quality to make sure that the soldiers sitting in these vehicles will return home safely.
There are currently 240 employees working on almost 30,000 square meters. It all starts with incoming goods. Countless small and tiny components manufactured by suppliers are initially sorted in this huge, fully automated high bay warehouse. More than 38,000 components have to be stowed away and ready to use.
In the automated warehouse, we have more than 3,000 places. So this is really big. Based on the production sequence, we follow that. And based on this, we pick up the necessary parts from the warehouse and send to the production.
Large components require more power, but no personnel. Fully autonomous automated guided vehicles, AGVs for short, transport the components to the next station. This saves time and personnel. This delivery is heading straight to the welding shop where the first segments are produced for the hull of the Lynx. This is welding work that needs to be learned. The Hungarian employees were trained beforehand in Unterlüß, Germany, as part of an exchange program. Before the plant opened, there were no qualified welders for armored steel in Hungary.
The difference is the material, because the armor steel it's more complex. That's why the guys have half-year training for this one.
The tank hull has now reached the next station, fully automatically, with the help of the driverless transport system. The lifting and turning station. There, it's suspended for thorough inspection from all angles. A scanner will perform this important inspection. The aim is to create a 3D model of the hull. Slowly, it's rotated into all the necessary positions. With dimensions like these, hand measurements are out of the question. The scanner takes over. Controlled by a robot arm, it moves along the hull, bit by bit. Then, a computer compares the dimensions of the component against the design data. This ensures that all surface points and geometries, in fact, match the specifications.
We have to rotate and lift it in certain positions first. So we have a position, then we scan the part which we can reach, and then we move the part in another position and we scan it again. And step by step, we can scan the whole body like that.
If all measurements comply with the standards, the assembly is ready for sandblasting.
The rough surface of the steel, it's not enough for the paint to stick on the surface. And you can see the welding seams, they are making marks on the steel plates, and we can remove or it can be disappeared during this process.
The blasting medium that hits the steel here is a special granulate. Later on, it's collected, cleaned, and readied for reuse. After treatment, the assemblies are immediately taken to the paint shop. They are primed right away to prevent surface corrosion. The process takes 39 hours in this rotating positioner. 120 surface points with more than 400 drill holes and threads are attached to the tank hull. In continuous use here, a CNC-controlled milling cutter. The condition of the tools themselves is also constantly checked. After each change, they're measured by laser and checked for wear. Specified wear limits must not be exceeded. Back in Unterlüß, countless truckloads from external suppliers arrive here every day. Rising production figures and the launch of series production ensure that parts are ready to ship nearly anywhere in the plant. Hungary is supplied from here as well.
We help with the start of production by preparing kit deliveries. This basically means that we pack the tanks into little bags and send them to our respective partner. And they then start to process, assemble and manufacture the items, depending on the agreed level of vertical integration.
It takes thousands of different small parts to build a single Lynx. And here in the warehouse, they have to be pre-assembled by hand for use on the assembly line. It's a good thing that sophisticated technology helps keep an eye on the big picture.
It's sorted in rows from 1 to 36, and then it always goes up to 8. Material numbers are always labeled. You can see what you have to take out. There's a laser up here, you can see it quite well. It moves from left to right or right to left, depending on where it has to go, and then basically it shows us where we should find the material.
But not all parts are installed immediately. Large parts are placed in the high bay warehouse and are only removed again when the vehicle has reached the respective stage in the production cycle. This ensures that there is always enough material available. Meanwhile, a special component finds its place on the production line. The tank is fitted with its engine transmission unit, its power pack. This is an inline 6-cylinder diesel engine with a displacement of 18 liters, a rated output of 1,155 horsepower and 4,300 Newton meters of torque. And this is precision work. The 4.5-ton unit is carefully lowered into the front part of the hull and later placed directly alongside the driver.
We always need to get it in there right, with a smooth fit and without friction, so it will end up resting nicely in its bay as it should.
The tank's tracks also have to fit securely. One hull further on, the important components are brought into position. For assembly, the Lynx is moved onto one half of the running gear with the engine idling. The other end is pulled over the rollers with the aid of a forklift truck. Bit by bit, the track chain of the running gear is tensioned around the rollers. In the long run, this would be too strenuous to do by hand, as each chain link weighs around 22 kilograms. The running gear tracks perform several functions. They distribute weight over a larger area, provide greater traction, and can withstand fire from enemy troops better than tires. The next step is to use a tensioner.
Here's the track tensioner. We'll put it on straight away on the open ends. Then I have a nut here. This is put on and then tightened with an impact wrench.
The running gear tracks are made of high-strength steel alloy, a material that helps overcome even the most extreme obstacles and withstand extreme loads. The work of fitting the links over the 6 rollers of the Lynx is nearly complete. The last link is lodged in place with a copper hammer.
Copper is a soft material. That way we don't damage the chain. If we were to use a steel hammer now, we would have incredibly sharp-edged splinters because these chain links are also quite hard. And a copper hammer is softer. But this way, the hammer still transfers the force.
20 minutes later, the running gear track is in place. It will remain there until the next service interval.
And that's how you put a track on a Lynx.
The work of assembling the armored turret is much more delicate. The Lance turret.
We can simultaneously feed 2 different types of ammunition, which can then be switched and programmed. Set the distance for the ammunition to detonate. If it's shot at, it can reload, reposition, move and return fire. So it's really impressive to see what's possible.
The Lance turret is connected to the chassis by a pivot bearing that permits it to rotate in a 360-degree radius. The main weapon is a 30mm automatic cannon. An onboard machine gun and an integrated weapons station are also installed.
Here in the turret, we have the crew of the commander here on the side. He also has a little bit of different equipment here. And here we have the gunner.
To link all of the systems together, a total of around 160 cables are laid in the turret alone. The most important component is the main weapon, the 30mm gun. The gun is inserted into what is known as the cradle construction.
We are in the cradle building business here. And you can think of cradles as the main structure in which the weapon sits, along with everything else that has to do with the weapon. It's called a cradle because it is always balancing the weapon. It is always in the cradle depending on how the turret is positioned and what the terrain is like, or where the tank is driving, and that always levels it off.
The cannon fires different types of munitions, including so-called airburst rounds. These rounds can be programmed to detonate at a precisely defined distance. 200 shots per minute are possible. The Lynx has 230 cartridges in the magazine. They are provided automatically from 2 independent ammunition feeds. A smoke grenade launcher provides additional protection in the event of a surprise attack. The smoke protection system, ROSI, fogs the battlefield over a large area. If the Lynx is attacked, a smoke screen can be created within a second. The main weapon in the turret is operated by the gunner. He activates and controls the weapons system and selects the ammunition that will strike its target with the greatest effect. Once the turret is fully assembled, it's commissioned and a test shot is fired with dummy ammunition. The weapon must be armed for this. The test can only start once the gunner has given the go-ahead to fire. The dummy ammunition is reusable. After the test shot, it's returned to storage. Now, The Lance turret is also being tested and moved for the very first time. The main weapon can be tilted from plus 45 degrees to minus 10 degrees. It can be swiveled 360 degrees. The main gun and turret are usually controlled by the gunner, but can also be controlled by the tank commander. The commander and gunner can zero in on different targets simultaneously and independently of each other, or have them tracked using automatic tracking capability. The technology for this, however, is and remains top secret. Not all Lynxes are the same. In prototype construction, the next variants are already in the starting blocks. Thanks to the modular base, different turrets can be attached, like this mortar, for example.
Then I have a range with this 120mm mortar ammunition, explosive fragmentation ammunition with a range of up to nearly 10 kilometers. So I can leverage the depth of space against the adversary, can fire to soften the target prior to attack, and can then attack the enemy at high speed with impact force, which is what an armored battalion of combat troops does, and then strike it accordingly.
Change of location. France. The biannual Eurosatory Arms Fair north of Paris is a must-attend event for the arms industry. It's a weapons show specializing in airborne technology that nobody wants to miss. And an exhibition and networking opportunity for those who want to buy and sell weapons technology. Nearly every army in the world sends its buyers here to view new variations and to hold talks with the manufacturers. Rheinmetall is also in attendance to present the Lynx in its different variations.
That's the big mix of, I would call it, initiating talks that we have with suppliers, but also with customers, right through to specific discussions with existing customers who are considering further collaboration, and including placement of follow-up orders.
Because the German manufacturer has developed the Lynx without an order, it's taking a risk. The Lynx is exceptionally versatile, which should attract potential interested parties. Italy, Ukraine, and the US are among them. Aside from its variable main weapons systems, the Lynx can be further upgraded. With the launcher for the Spike LR2 guided missile, for instance, an important weapon in battle. Positions and enemy tanks can be fought at distances of up to 5,500 meters. Both the gunner and commander have access to the system and can adjust the target and angle of attack at any time during the flight of the projectile. Back in Germany, this is where the Lynx was developed. Here is where the first models of each variant are built and where series production is launched. This model is on its way to a special check, the leak test. Specially mounted plates on the sides and later on the turret simulate the system weight. The crew is preparing for the upcoming bath. The tanks also need to be filled before the leak test. Company grounds in Unterlüß feature a dedicated filling station for all tank models. 400 liters of fuel have already been filled. The rest will now follow. The Lynx needs fighting weight for the leak tests. The red stripes on the plates mark how deep it has to be submerged.
When fully loaded, the vehicle has armor and a full tank. It has less ground clearance and sits lower to the ground as a result. And with empty tanks, for example, and other armor modules, the vehicle is higher again. And so we falsify the measurements, so to speak, and we also use these auxiliary lines to recreate the target state as precisely as we can.
An armored fighting vehicle is refueled just like a car. except that these fuel tanks can hold significantly more diesel. The Lynx has 9 fuel tanks that hold a total of nearly 1,000 liters of fuel. That takes time.
An estimated minimum of 5 minutes. Every now and then we have to wait a little longer until the fuel distributes itself in the tanks. This means that our colleagues keep switching between left and right, refueling a little more until we've reached the actual maximum level.
The Lynx must prove to be 100% watertight in the upcoming test. Waterproof on the one hand when the vehicle and crew have to go to depths to cross rivers or lakes. On the other hand, the tank must also offer soldiers the best possible protection against nuclear, biological, and chemical weapons. We're ready to go. Entering the so-called deep wading basin, which is filled with around 150,000 liters of water. Every new tank is submerged here, even before the turret is installed. More and more water is added until the water level reaches the red lines on the side panels. Now, the vehicle has to stay in the water for 15 minutes. Then, the test is over and passed. After around 14 weeks of assembly, at this stage, the Lynx is nearing the home stretch of its journey through production.
Now we take the vehicle back into the hall and then open the engine compartment again to see if everything is still watertight. That's the final test. And then we're expecting the turret soon.
When the turret is integrated into the chassis, it's a festive occasion. This connection is referred to as the wedding. To do this, first the lance turret, weighing around 6 tons, is attached to the crane. The length of the 3 chains is particularly important here.
Chain link lengths are different because the weight distribution is different due to the asymmetry of such a turret. It's so that you can withdraw the support horizontally.
The turret has to be lifted horizontally out of the fixture with great dexterity. The cage must not be damaged under any circumstances. Later on, this will protect the commander and gunner during rotation of the turret. The lance turret now makes its way to its vehicle and the upcoming wedding. It's a precision task to put it in place, slowly and horizontally to ensure a perfect connection. Done. After 12 minutes, the lance turret is in place on the Lynx.
The turret is up now without a collision. That was good. The next step is to remove the chains. Then there are all the electrical connections, connection hull, tower, and then the system as a whole is commissioned, tested, and then we hope for a good marriage.
Before delivery, however, there is still one last firing test to pass. The functionality of the overall system is put to the test once again. And that involves every single weapon on board, with fire from literally all of the guns. This is where the onboard MG is finally tested. The machine gun is loaded for this purpose. The Lynx can be equipped with various weapons depending on customer requirements.
Today we are shooting the MG, Mac 58, a Belgian machine gun, which is used here as an MG gun mount for the weapon, installed in the entire system. Fires 7.62mm rounds.
The main weapon of the Lynx is the 30mm automatic cannon, which can be fed with various types of ammunition. airburst rounds, which can be programmed to detonate in front of, above, or behind the target. But the onboard machine gun has to be fired too, to ensure that both the weapon and the aiming device are properly sighted in. Therefore, several bursts of fire are fired at a target 100 meters away.
The overall system is what counts. All three weapon systems installed in this vehicle have to harmonize with each other. It's a very complex system.
Bremen. This is where Rheinmetall's Competence Center for Electro-Optical Systems is located. This is where the Lynx gets its eyes and ears. The SIOS, Stabilized Electro-Optical Sighting System, provides particularly sharp resolution. A digital sight with target acquisition is integrated into the weapons systems.
The main sensor of this weapon station is the SIOS. This is a stabilized vision system that enables the commander to observe up to 5 kilometers and other targets up to 20 kilometers around the tank, and then to also initiate the firefight.
The system recognizes targets and tracks them.
The SIOS enables distance measurement, but it also enables tracking, that is, automatic tracking of the view as well as the turret and the weapon station, keeping the line of sight trained on the target at all times without any intervention by the operator. This permits something like permanent surveillance, even while the Lynx is moving.
A rotating base like this provides the basis for the weapons station. It allows for 360-degree rotation. The base plate of the SIOS is attached to it. It contains the electronics. Post-assembly is pre-test. The rotational capability of the weapons station and main optics is tested. After all, the tank commander and lead gunner will need a permanent, all-round view. The complex vision system also has to pass an endurance test.
This is a cold chamber, or a temperature change chamber, in which we subject the SIOS to a special stress test. From -46 to 49 degrees Celsius. Can the SIOS display everything it is supposed to under these adverse conditions?
There are also 6 camera systems like this installed to provide all-round protection for the tank and crew.
We've implemented an automated tracking function on the panoramic strip so that the entire vehicle crew has information available at all times as to whether there's movement around the Lynx, and the movement can then also be categorized. For example, whether it's a person, a group of people, a vehicle, or even a classification of individual vehicle types, as well as friend or foe recognition.
With the hatch closed, the cameras are the eyes of the crew. They have to function at all times, day and night, and in any terrain. And they have to be robust. To ruggedize the powerful electronics against the elements, the housings are flooded with nitrogen during final assembly.
The nitrogen has been purified. It is completely dry. This means all the air it previously contained and the humidity is removed from the device. And at the end, we check whether there is any leakage at very, very high pressure.
In Unterlüß, where the first models of each variant are built and series production begins, the nearly finished vehicles are now given a visual finish. In the paint booth, cameras monitor every move. It's not about watching people, but about their health and the material. The paint is applied with pinpoint accuracy, and vapors are evacuated immediately.
Our spray booths have a vacuum system that employs 6 ceiling-mounted cameras. You can select where work is being performed. Then the spray mist is evacuated, so you could actually work without a mask.
The Lynx has its own tank forge operation in Zalaegerszeg. The NATO member state is introducing 209 KF41 combat vehicles into its armed forces. From armored fighting vehicles to ambulances, the Hungarian army will be outfitted with 7 variants. The first 46 Lynx are manufactured in Germany, all others here. Lynx manufacturer Rheinmetall and the Hungarian government are proud of more than just the plant and its test center. They are also proud of the speed with which the ultra-modern complex was built.
We started building here in spring 2021. Today, this is the most modern tank factory in the world.
The test facilities are a flagship. Every Lynx is put to an extreme test here. First, in the measuring hall for testing electromagnetic compatibility, EMC for short. The entire system is equipped with absorbers. Now, the vehicle has to demonstrate that it can withstand the external interference signals.
I introduce the relevant radiation from outside. My electrical equipment works as usual, then everything is okay. There's a lot of electrical equipment. Electrical devices are installed in the vehicle where, of course, we have to make sure that they don't affect anything in the surroundings either.
This is because any electromagnetic emissions to the outside world can be hazardous when detected by enemies. So, it's important to accurately measure the electromagnetic signature of each tank. The Lynx is positioned on a rotating platform to test its internal and external resistance. This way, the armored fighting vehicle can be irradiated and inspected from all sides. If this test is passed, the next one already waits. Entry into the so-called climate chamber, where very special weather conditions prevail. Here, engineers can simulate every climate zone in the world and generate temperatures between -50 and +85 degrees Celsius. And a maximum humidity of 95%. Certain climate zones can also be supplemented with simulated sunlight. After all, the Lynx is designed to operate not only in snow and ice, but also in hot desert missions. The next test station has a great deal to absorb. These underground halls are used for live firing. Here, tank turret systems have to prove their firepower and accuracy. Test firing can be carried out at a distance of up to 200 meters.
Of course, the ammunition has to be collected somewhere. And we have appropriate materials behind the target area to collect the ordnance that has exploded.
The very last tests are conducted in the open air, on the company's own racetrack, decelerating from a top speed of 70 kilometers per hour to a standstill. That's what the Lynx has to do here. The big test finale is uphill, with just one more small climb to go, a 60% gradient to be precise. Every vehicle must be able to climb this slope and then park in this position for exactly 10 minutes. Every Lynx, every tank variant has to pass extensive endurance tests before it can be delivered and deployed. And deployments are evolving. AI on the battlefield is changing warfare, even for the very latest armored fighting vehicles. The modular design of the Lynx enables quick adaptations and improvements. A large team of engineers and designers ensures that the tank never stops evolving.
But this is a very complex vehicle in an ever-changing phase of warfare, and that means we have to adapt. The design have to adapt as well. And this architecture gives room for that. So we kind of helping this product evolve and getting more and more mature to have it more efficient, more survivable, and more usable for the troops.
July 2024. The first Lynx made in Hungary is completed. The photo opportunity at the assembly line in Zalaegerszeg is a festive occasion.
3, 2, 1.
This marks a milestone because Hungary is the first nation to put the Lynx into service with its armed forces. With a planned service life of 40 years, the armored fighting vehicle will be in use until at least 2064. 2 transport robots work in tandem to lift the 45-ton vehicle. The first Lynx, ready for handover. This occurs the next day on the grounds of the tank forge, accompanied by a big ceremony. Soldiers, management, employees, the whole factory is on its feet, together with representatives of the press from all over the world. The Hungarian Minister of Defense has announced his attendance. The first Lynx produced in Hungary will be ceremoniously handed over to the armed forces. As a NATO member state, the country is also an external border of the EU. And then, just 2 years after the cornerstone was laid for the plant in Zalaegerszeg, the time has come. The first Lynx armored fighting vehicle produced entirely in Hungary leaves the hall to enter service with the Hungarian Armed Forces. $162 more will follow. From the outset, having a production facility of its own was an important part of the Hungarian plan.
We did not just want to procure new fighting vehicles for the defense forces, but the other goal was also to develop or reinvigorate the Hungarian defense industry. And I think it's a big milestone for the defense industry sector that now the first Hungarian-made fighting vehicle is out of the factory.
The first crews are ready too. They have completed their training on the Lynx tanks in Germany and are confident in their new workplace.
When the doors close, you forget about the world around you. It becomes very quiet and you concentrate on your orders. The only priority is to steer the vehicle safely. You switch everything else off. It's all about getting from A to B.
New things are also being built at the German location in Bremen. There, work is progressing on the Infantryman of the Future system, a system that upgrades soldiers, networking them with one another and with the Lynx. This way, enemy contact can quickly be shared with all units.
He can enter it by hand by just inserting a point of interest into the system. Then he can define the point of interest. This means that the commander in his vehicle, the Lynx armored fighting vehicle, has direct information about the enemy's battle tank in position, and now he can make decisions.
The crew can also paint the point of interest, the target, with a laser. Coordinates are then transmitted in real time to other units via the Lynx network, to artillery units, for example. The entire technology for this fits in a pocket. A Lynx commander has long had the capability of issuing orders to dismounted personnel via tablets in the vehicle, even without radio communication.
Now I'll go to our sketch function. It works just like paint. You can imagine how it works. And then I would define a simple attack case here. That looks like this. Which means that if there's a unit here, they attack the enemy along this path, send it to the group, to my platoon, and to the higher level command. And now, after a few moments, the whole thing should appear right here in all systems at the same time.
Every soldier's digital networking and equipment is crucial to the effectiveness of the armored units in combat. But classic voice connections are still an integral part of communication. So audio quality is constantly being put to the test in the laboratories in Bremen. Headphones and microphones are tested in this sound laboratory under battlefield noise conditions.
We're here in the audio lab and we optimize the entire audio chain, from microphones to radios, and ultimately back into the headset to the loudspeakers. We make speech intelligibility measurable, so when we make adjustments, we can see directly whether there's been an improvement. And we don't need the original equipment, the tank in the field.
Security area. The latest driving simulator for the Lynx armored fighting vehicle is located here. High-tech for drivers who can train around the clock.
In other words, we train via hatch with the hatch open. That's usually moving on the road or maneuvering at the, at the barracks, like when you pull into the vehicle to pose. Then you can do this with the hatch open. And in combat, you have the hatch down. Then you lower the hatch, and then you can train those scenarios here too.
And all scenarios are possible here. An instructor monitors the driver during the exercise and can intervene and modify the scenarios at any time. This turns the simulator into a real experience for the driver and a realistic endurance test, because especially the extreme situations are also trained here. Navigation under enemy fire, for instance. No other tank has ever had a simulator like this, one tailored to its driving characteristics.
This is the first of its kind and will be followed by other driving simulators, shooting simulators, and desktop trainers. Later on, the whole thing will become a simulator center at the customer's premises where the customer does the training.
It's a masterpiece of engineering. The Lynx KF41 armored fighting vehicle, designed to meet the demands of the battlefield of tomorrow. Its modular weapons systems set new benchmarks in modern defense. It delivers speed and firepower. NATO member Hungary is the first nation to rely on the Lynx and has built its own production facility dedicated to it. The Lynx was developed by German defense giant Rheinmetall. The ramp-up to series production began in Unterlüß. Regardless of the variant, the first tanks are always created here. Its mobility, its immense firepower, and its advanced armor protection give the Lynx a decisive edge on the battlefield and make it the ultimate tool for every mission. High-tech made of steel. Technology built with soldiers' safety in mind.